Hi, fifth grade scholars. We're here today with our next lesson. You're doing this one on your own because it's very, very similar to what we did yesterday. So we are still going to do the box method. That's what we're learning right now is how to break up that number and make a box method. So let's go ahead up to the top. Today we're going to be doing 3-digit numbers by 2-digit numbers. So it says there are 128 pens in a full box. How many pens are in 35 boxes? So in my head, I'm thinking, okay, I've got 35 boxes. There are 128 in each box. How am I going to do that? So it says model it. Use an area model to show the products. Sketch a rectangle with the dimension 128 by 35. So this is what they've done for here. So 128 in this red lettering is the same as 100 plus 20 plus 8. There are many ways that we could write this. I'm going to get my comment button. I mean, I could change this up here and I could say, am I in red? Let me get red. I could say 50 plus 50 plus 20 plus 8. I could do that same thing because 50 and 50 is 100, 120, and then 128. But we're going to do the way they want them to do. But what we're actually doing is breaking that number up into smaller numbers so it's easier for us to multiply. One of the great things to do is have the zeros, because the zeros, as we continue to practice, you're going to see those are really nice and easy to use. So let's get rid of what I just wrote here. Maybe. There we go. And let's just use what they've given us, which is 128. And then the other number up here was 35. So they've divided the 30 into 30 plus 5. So they've drawn this box, and we've got 6 compartments in that box. And the reason that is because we've got 3 numbers by 2 numbers. And 3 times 2 is 6. So that's how many boxes right now we're going to have. But I just draw a box and I start at the top. I put my 100, my 20, and my 8. On the side, I put my 30 and my 5. Now, they've color-coded this to help you with your, to be able to see this. So the 100 is down here in the red, and the 30 is over here. So it's a little bit like doing tic-tac-toe or lining up the graph, or lining up the squares. I don't know what you want to call it, but 30 times 100. Remember that we've talked about those zeros when we're multiplying. So what I'm basically doing is looking at that 3 times 1 and writing it and thinking, how many zeros do I need to add to it? I need to add 3. So the answer to this box, 100 times 30, is 3,000, and they put that in black for you. The next one is going to be right over here. We're going to have 30 because we're still in the 30s area all across here. 30 times 20, 3 times 2 is 6, and 2 zeros. I love those zeros. And then our last one is 30. We're still in the 30s row. And then in the column, it's 8. I know that 3 times 8 is 24. Add that 0. Now I'm not done because I still have to do the 5. Now you might wonder, why do they make this one so big and this one so little? And that's so that you can see that 30 is a bigger number than the 5. The same thing when you look the other way. 100 is bigger than 20, which is bigger than 8. So they're kind of making their boxes in comparison to the size of the number. It's up to you how you do it. That's nothing that we're going to look for, but it kind of just helps us remember that we ought to have larger numbers in those. All right, so now we're on the bottom row. So 5 times 100. 5 times 1 and add 2 zeros. So we have 500. 5 times 20 is 100, and 5 times 8 is 40. Now, what do we do with all those numbers? We add them all together. But if we're not careful, we'll mess that up. So I really suggest that we go across the top row and across the bottom row, which is exactly what they do here in the book. So in our top row, we have 3,000, which they show us right here. Oops. There, I was trying to get my flashy thing. 3,000 plus 6,000 plus 240, and we get 3,840. That's only for the top row. Now we have to do the second row, which is 500 plus 100 plus 40, and we end up with 640. So when we add those two numbers together, we end up with 4,480. So what we can see is that 128 times 35 equals 3840. All right, let's move on down the page. This is like that partial product, and I'm going to whiz all the way back up here that we looked at yesterday. This kind of shows, if we go back, we did this one in class. This one is 127 times 46. And what they did was they took 127 and this 46 in red, they decided, let's break that apart. Let's do partial products. So part of the 46 is 40 and part of the 46 is 6. So they decided not, so this is partial product, not to break apart that 127, but to be able to break apart the 40. And then you multiply 127 times 40, 127 times 6. You add those two partial products together and got the answer. So we're doing that same thing today down on this one, except for they've got it lined up horizontally. They call it the distributive property. There are multiple properties that we'll be talking about, but this one's distributive. Again, let's look at the red and the blue numbers. So the red, 128 times 35 equals, they're leaving the red number, the 128. They're leaving that as a whole number. They're not breaking that one apart, but we are breaking the 35 apart. So we're going to say that it's 30 plus 5. And we know that 30 plus 5 is 35. So let's go down to the next row. So we're leaving that red, that 128 alone, but we're multiplying it by 30 plus 5, which actually means, and I'll get my pen up here, that this one in 28 is going to be multiplied by that 30, and then it's going to come back and it's going to be multiplied by that 5, which is what they're showing you right here, is that 128 times 30 and then 128 times 5. So now let's come down here and look at how we actually do the multiplying. Now this is from 4th grade. You might have got some of this before the COVID struck and we were home in school. So we don't have any ones down here. So we're not going to go 0 times 8, 0 times 2, 0 times 1. We're not going to do it that traditional algorithm way. What we're going to do is we're going to look at this whole thing, this whole 30. And we're going to say this 30 times 8 is right here, and it's 240. Now we're done with the ones. Now we're going to do 30, and we don't do 30 times 2 because this is sitting in the tens place. So it's really 20. Remember, this would be like having 2 of the longs. So it really means 20. So 30 times 20, which is what they've got right here, is 600. And then the last one, this is in the hundreds place. So that's like having one of those flats. And I'm not going to be able to draw very good. I don't have a stylus. I'm using my mouse. So I'm just not a very good drawer doing this. Okay, that's a flat, and it's 100. So 30 times 100 is 3,000. Add all those together and you get that. Now we're not done because we did the 30. Now we have to go over here and do the 5, which 5 should be pretty easy. 5 times 8, 40. 5 times 20, 100. 5 times 100, 500. Add those together and we have another partial product. A partial and a partial, we add those together and look what we have. We have an answer that matches the same answer that we did up here. So this is the box method up here. This is partial product down here. Today you're going to be practicing with some more box method. Right, now let's see, what do we have to answer down here? It says, why is the area modeled into 6 sections? Well, if you think about it, because the products, because the first product, which was, I think, 128. Let me go back up. 128. The first product, comma, 128, has 3 numbers. And the second product has 2 numbers. So before we go any farther, I want you to think, if we had 3 numbers across and 3 numbers down, how many boxes would we have? We'd have 9. So the more we have across, the more numbers we have to add. So we want to try and think about that. We don't want to end up with 12 and 15 boxes to add. That's too much. So this one is because the product had 3 numbers and the second product has 2 numbers. And that's why we have 6 sections. We had to divide it into rows. And again, if we think about that, we knew that we had 3 numbers, so we were going to put a number here, a number here, and a number here. And then the bottom one, we had a number over here and a number over here. So when we finished drawing that table and dividing it, we had 6 numbers. So if I had another number down here, which is what we just talked about, this right here, then we'd have 9 boxes. So how many ever digits you have in the first number, how many ever digits you have in the second number, we multiply those together. That's how many boxes that we would have. Now, let me see if I can find that eraser. I don't know if I can erase this. I got all the way down into our next problem. Okay, that's close enough, right? Okay, now back up to my pen. Okay, so how do 3 partial products in each multiplication in the second, I think it says row. Oh, in the second model, I see. Okay. How do the 3 partial products in each multiplication equation in the second model relate to the 3 sections in each row of the top model? So what they're saying is, how does this 3840 compare up here? So what we did up here was we took 30 and we multiplied it by 100, then we multiplied it by 20, and then we multiplied it by 8. And we did the exact same thing down here. And then we took, I'm going to grab a different color pen, I'll take green. Oh, I guess I can't do that. Okay. I don't know what I'm doing here. Then the second one, we had the 5, and we multiplied it by the 100, then we multiplied it by the 20, and then we multiply the 8, and that's the same thing that we did down here. So now when we go back over to this, it says, how do the partial products, that's the bottom part of the page, in the multiple equation, in the second model it, relate to the 3 sections in the top one? And the way that they'd like you to answer that is they say each partial product, which means, you know how we split those numbers up. Each partial product is an equation in the same, each partial equator is an equation in the same, I am so totally messing up here. Each partial product in an equation, that's where it is, in an equation is the same as the partial product in one section of a row, in one section of each row. So let me go back and just clarify that one a little bit. What they're saying is, each partial product that we came up with down here, that 240, that 600, those are also partial products up here. Okay, so 30 times 8 was 240. 30 times 20 was 600, and the 3,000. So these products right down here are the same as they are up here. Okay. Would the product change if 30 and 5 on the left-hand side, so when we drew that box, is what they're asking you, when we drew that box, they did 30 and 5. Would the answer change if we did 20 over here, and then we did 10 over here, and then we did 5 over here? Would it change our answer? No, not at all. It just means more boxes and more multiplying, because we'd have to do it 3 times, and then we would still have the 128 up here, so there'd be the hundreds, there'd be the 20s, and there 8. When we add it all together, it's still going to be the same answer. It's just more boxes and more multiplying. List 2 different ways that you could break up the factors 239 and 64 to find the product. Now remember yesterday I talked to you about we have to know factors and products. Factors are these 2 things right here, 239 and 64. The product is the answer. So explain both ways, and would they have the same product? So this one, I could do 200 plus 30 plus 9. Whoop, not 0, 9, not 0, 9. I could do that one. And then on the next one, the 60, I could do 60 plus 4. Now it says to give us a different way. So the different way, I could do 100 plus 100 plus 30 plus 9. And how could I do this one if I wanted to? I could do 30 plus 30 plus 4. Now again, that would require a lot of boxes. This is four numbers. This is 3. That means 12 boxes. That's a lot of boxes, and I wouldn't suggest it, but we can do it. And are we going to have the same product? Absolutely, because our numbers, our whole number didn't change. It's just that we broke it apart in 2 different ways. So now I'd like you to do the try it on your own. It says just using what we've used before and multiplying numbers to solve this problem. Show your work on a separate piece of paper. If you've got room up here on your paper, you can do that. A bookshelf at a library holds 156 books, and there are 15 shelves. How many children's books can be placed in the library on the shelf? So you have to show your work. I don't care if you do a partial product or if you do a box method, but I want your answer down here, and then I want you to come and get it checked by either Miss Downer or myself. Don't forget to label it. Okay, hope this lesson helps. Have a great day.